Good morning, this is Dr. Jingbo Louise Liu. Today we are going to finish your chapter 2, the components of matter. We are going to be more focusing on the last topics related to the nomenclature. Before that, I want to give you a very brief overview about our periodic table. In your periodic table, you should find different groups, different periods. You're also going to find representative elements. Also, you have a transition element, metal, non-metal, alkaline metal, alkaline earth metal, chalcogen, halogens, inner transition metals. In the other following chapters, we are going to be more specific about the periodicity. So today, we are going to be focusing on the nomenclature of different compounds. Generally speaking, we are going to be discussing 3 different types of chemical bondings. The first one is called ionic bonding, related to the ionic compounds. Second one related to covalent bonding. We are going to be discussing covalent compound nomenclature today. Another bonding will be metallic bonding. So again, these different chemical bondings, we are going to study them more detailed way in chapter 9. We are going to focusing on nomenclature of different types of compounds today. First of all, we are going to name the binary ionic compounds. In order to name the binary ionic compounds, we need to follow 4 rules. First of all, for all ionic compounds, the name and the formula list the cation first and the anion second. The binary ionic compounds, both cation and anion, are monoatomic. The name of the cation is the same as the name of your metal in your ionic compounds. Many metals name end in IUN, such as sodium, calcium, lithium, etc., etc. The anion named by adding a suffix IDE to the root of the non-metal name, such as oxygen, you name it to oxide, nitrogen to nitride, chlorine to chloride. For example, we have calcium Ca reacted with bromine to form calcium bromide, CaBr2. In this table, listed different charges: positively charged, negatively charged, +1, +2, +3, commonly used cation formulas, and also the related names. Particularly, I want to mention a couple of them. In your group 1A, also called alkaline metal, lithium, sodium, potassium, cesium, they are +1 in charge. Silver Ag also +1. In your group 2A, magnesium, calcium, strontium, barium, they are 2+. Your zinc and your cadmium, they are 2+ as well. +3 for your aluminum, that's in your group 3, 3A or 13. Negatively charged ions, such as your halides, fluoride, chloride, iodide, bromide, they are -1 charge. -2, such as the typically used chalcogens, oxide, sulfide. Group nitrogen, then nitride, so you will have, that is group 15, 5A. So 3 negative, that's a different monoatomic ions, positively charged, negatively charged ions. This table will be very useful for your future study, particularly when you're writing down the accurate molecular formula. You need to know the charges. I believe in our previous class, I asked everybody why your calcium bromide written down by CaBr2. Right now you should have the answer. Calcium you have 2 plus, bromide -1 charge. Therefore you need to balance off your charge. That's why your calcium bromide has the chemical formula CaBr2. Sample problems about naming binary ionic compounds. Again, we are going to follow the IUPAC convention for all the nomenclatures. The problem including 4 different groups of substances. Name the ionic compound formed from each of the following pairs of the elements. Pair A, magnesium and nitrogen. B, iodine and cadmium. B, C, strontium and fluorine. D, sulfur and cesium. Again, as we usually do, we must have a plan. And then you come up with your solution. What the plan is, you are going to use your periodic table, determine where your element is located, whether the element is metal or non-metal. And then you are going to need to know what is the charge, what is the positive ion and the anion. If you have the non-metal, so you need to know to change the non-metal to the IDE suffix. For example, first one, magnesium and nitrogen. Your magnesium is in your group 2. Imagine your periodic table. In the back of me, you have your periodic table, group 2. So magnesium 2 plus. Nitrogen, a couple minutes ago, we showed you nitrogen has 3 negative. Therefore, nitrogen is a non-metal. Magnesium is a metal. Metal will be positively charged, non-metal will be negatively charged. Therefore, your non-metal will change the name from nitrogen to, yes, nitride. Magnesium maintains its own name. Therefore, the pair A, you call it magnesium nitride. Also, I have take-home message for everybody. What's the accurate chemical formula for magnesium nitride? Pair B, you have iodine and cadmium. Cadmium is a metal, iodine is a non-metal. Iodine, you change it to iodide. Yes, the name will be cadmium iodide. The formula will be CD(I2). This name, more accurately, we should call it iodium parenthesis 2 Roman numerical value close parenthesis iodide. Cadmium 2 iodide, because this cadmium is your transition metal. Pair C, you have strontium, which is a metal from group 2, fluorine, which is a very typical highlights from your group 17 or 7A. Therefore, your name for pair C will be strontium fluoride. Pair D, sulfur, non-metal, cesium, metal. Sulfur usually occurs as a sulfide, 2 negative, so therefore the name for the pair C will be cesium sulfide. Sample problems again to determine the formulas of the binary ionic compound. Close to what we did, and actually essentially the same as your previous sample example. Actually, it's from 2.7. You have magnesium nitride, cadmium iodide, strontium fluoride, and cesium sulfide. What's the chemical formula? Again, your plan is, number 1, your compound, all of these ionic compounds, they must be neutral. Number 2, you need to know the smallest number of each ion, which is going to produce a neutral formula. Number 3, you need to write it down, the red subscript to the different relevant elemental symbol. And also make sure you balance off your charge. solution. For the magnesium nitride, you have a magnesium 2 plus, nitrogen, which is in the group 5A or 15. So you have nitrogen 3 negative. 2 plus, 3 negative, you need to balance it off. Your magnesium, you need to multiply by 3. Nitrogen multiplied by 2, make it to positive 6 and negative 6. The formula is Mg 3 and 2. Make sure number 3, number 2 must be subscript. Second pair, cadmium iodide. Your cadmium is 2 plus. Iodide is from your group 17 or 7A called halogens, -1 in charge. You need to make these compounds neutral by +2, -2. Therefore, the formula will be CdI2. Yes, thank you. And your number C, strontium fluoride, strontium 2 plus, fluoride -1. You need to again balance off the charge. So you have SrF2. The last one, cesium 1 plus, sulfide 2 negative. So you need to balance off the charge by 2 plus and 2 negative. Cesium need to multiply by number 2, which must be subscript. Yes, CS2S. There's some very commonly used polyatomic ions. Can be positively charged, can be negatively charged. Commonly cations such as NH4 plus. You call it ammonium. H3O plus is called hydronium. Commonly anions such as acetate, that's your acetic acid, which is a commonly used household vinegar, cyanide, Cn negative hydroxide, and we are going to name these groups called oxoanions, such as hypochlorite, chloride, chloride, perchlorate, etc., etc. I need to remind everybody about this nitrite. Make sure NO2 negative is called nitrite, NO3 negative nitrate, carbonate, bicarbonate, chromate, dichromate, peroxide, oxide, they are different. And your sulfate also are very different. This table listed the commonly used polyatomic cation and anion. I also suggested either print it out or save it to your iPhone. Keep it handy. It will be very useful for your future study, particularly when you balance your chemical reaction. You do need the accurate molecular formula. Followed by, we are going to show you the oxoanions, such as ClO4 negative, ClO3 negative. So what you see in your polyatomic ions, you have the different number of oxygens. Oxygen you have number 1, 2, 3, 4. They are negatively charged ions. Therefore, you call them oxoanion because you have different number of oxygens. In this kind of oxoanion substances, you need to know prefix. You also need to know the root. And then you need to know the suffix. The prefix, you have something we call per, related to the high oxidation number of that element, the root element. Such as if you have a ClO4 negative, this compound, you have a suffix called ATE. This compound is named based on the chlorine. You change the chlorine to chlorate. That chlorine, CHLOR, that's your root. And then you added AT. Change your chlorine to chlorate. Because you have a large number of oxygen, you call it perchlorate. ClO3 negative, you call it chlorate. Similarly, if you have ClO2 negative, you need a suffix, you need the root. The root again is from your chlorine. You change your chlorine to chloride, I-T-E. So this is negatively charged ion called chloride. And the last one, ClO negative, you also need a prefix called hypo. Hypo meaning low number of oxygen. Correspondingly, this Cl has a low oxidation number. You call it hypochlorite. If you have a little later called binary covalent compounds, not ionic, covalent, meaning you have two nonmetals, they are going to be bonded together. So you call the binary covalent compounds. Most of the cases, if you have hydrates, you also need numerical prefix, such as if you have the number 1, 2, 3 all the way to 10, you have different prefixes, such as number 1, mono, 2, di. Sometimes you also see bi, bi, 3, tri, 4, tetra, 5, penta. How about 10? Yes, deca. Octa means yes. Number 8, hexa. Number 6, 7, hepta. 9, nona. Above 10, I will leave it for everybody to study by yourself. Sample problems to determine names and formulas of the ionic compounds containing polyatomic ions. Problems. Gave the systematic name. This nomenclature is based on the IUPAC convention. Gave the systematic name for each formula, or the formula of each name for the following compounds. A, FeClO4 2, sodium sulfide, BaOH2, 8, H2O. So if you have the formula, how do you name it? If you have the nomenclature, what's the formula? The plan. Remember to use parentheses when you have more than one unit of the particular atomic ions is present in your compound. And then also you need to know the charge. First one, A, ClO4 negative, that one is your oxo anion, which you call perchlorate. Your Fe need to have accurate charge, because your perchlorate negative 1, your Fe must have a positive 2 charge. Therefore, you balance off your compounds. This Fe is located in the transition metal. Therefore, the charge for Fe need to be identified using Roman numerical value in parentheses. The compound name is called the ion 2 perchlorate. B, sodium sulfide. Sulfide, SO3 2 negative. If you don't know, go back to your table. I listed the table composed of the commonly used polyatomic ions. Sulfide has a formula SO3 2 negative. So therefore, your sodium, which is a positive 1 in charge, you must have 2 of them. So this number 2, you use subscript. So Na2SO3. That's the formula for your sodium sulfide. The last one, C, you have an ionic compound, which is a Ba, barium, OH, called hydroxide, and you also have a hydrated compounds. This number 8, you are going to use octa, the prefix for the different number, and H2O water, you no longer call it water. When water is included in the formula as a hydrate, you use the term hydrate to name the water. And the number of this water, you have 8 of them. That prefix So you use octa to represent the number of your molecule water, which is the hydrated compound. The name for this compound is barium hydroxide octahydrate. Barium, sodium, they are from the main group element. You don't have to label the charge. Otherwise, such as ion Fe, which is the transition metal, you may have different charges. In this case, you have to use the new Roman numerical values to identify the charge. Put the charge in parentheses. Sample problems. These several compounds, I have some problems. I name it in an inaccurate way, incorrect naming. Identify it and then show the accurate nomenclature. A. This one BaC2H3O2 is called barium diacetate. Yes or no? You're right. That's not right. So barium is your cation monoatomic cation, and your C2H3O2, that's called acetate, negatively charged ion. So in your ionic compounds, the prefix is not necessary because the charge will tell you about the number of this acetate. So therefore, your accurate name just simply by barium acetate, remove di. The second one, B, called sodium sulfide. Sodium sulfide, FIDE. Sodium sulfide has a formula Na parenthesis 2 SO3. What's the problem? This formula has two problems. Number one, sodium is Na plus. Sulfide, by the way, if you have the single element, you do not need parentheses. This parenthesis is not necessary. Sulfide has a formula S2 negative. SO3 2 negative called sulfide, ITE. Sulfide S2 negative. Sulfide TE,糖 ITE is sulfide SO3 2 negative. Therefore, the correct formula for sodium sulfide DE is Na2S. Third one, ion 2 sulfate has a formula Fe2SO3. This one is wrong. The reason is ion is 2 plus. Sulfate has a negative 2 in charge, 2 negative. Therefore, 2 positive, 2 negative, you need 1 to 1. The formula for this ion 2 sulfate will be FeSO4. Yes. The very last one, cesium carbonate, has a formula CS2CO3 parenthesis. This parenthesis, possibly you don't need it. Let's see. The parentheses are not necessary since you only have one polyatomic ion is present. The accurate formula will be CS2CO3. Yes, thank you. Naming the acids. You have two types of acid. One of them is called binary acid, another one called oxo acid. The binary acid solution can be formed when you place or dissolve a certain gaseous compounds into water. For example, when the gaseous of hydrogen chloride, HCl, hydrogen chloride dissolved in water, you are going to form a solution which is called hydrochloric acid. In this nomenclature, you need 4 parts. 1, hydro. 2, the anion non-metal root, like your chlorine, chlor, and then your suffix, IC. Change your chloride to chloric, followed by the acid. So hydrochloric hydrochloric acid. Hydrochloric acid for this HCl, which is dissolved in water. You have hydrobromic acid, hydrofluoric acid, hydroiodic acid, etc., etc. Second types of acid is called oxo acid. Those oxo acids name are very similar to the oxo anions, but you do need to change your suffix to something else. For example, if you have ATE chlorate, you change ATE to IC. Chlorate change to chloric, followed by the acid. If you have a prefix per or hypo, maintain these two. So ITE, if you have your ITE chloride, change ITE to OUS. Just let's say chloride, chlorous acid. For example, I have BrO4 negative. This BrO4 negative is your perbromate. You form an acid by combining with hydrogen. You produce this HBrO4, which is called perbromic acid. Change ATE to IC. This per is going to be retained. Another compound which is also oxo acid, such as HiO2, which is produced by combining hydrogen with your iodide, IO2 negative iodide. Change your ITE to OUS. This compound, this acid, you call it iodous acid. Iodous acid. Sample problems. Determine the name and the formula of the anion and acid and associated acid. Totally, you have 5 different samples. The first one is related to Br negative. So what's your solution? The plan will be number 1, focus on whether it's negative charge or positive charge. We already tell you this negatively charged ions. If they are monoatomic ions, when they form the acid, make sure you have that hydro in your molecule. So you have your Br negative called bromide, which is negatively charged ion. The acid will be hydro, yes, bromic acid, HBr, yes, HBr is called hydrobromic acid. B, iodate, iodate. The anion iodate, you change ATE to IC. The compound will be, the acid will be named as iodic acid. Iodic acid, its formula will be HiO3. Simply put H in front because it make it neutral. Third one, Cn negative. Anion Cn negative is called cyanide. Therefore, you form a compound by adding hydrogen to this cyanide. So you call the hydrocyanic acid, HCN. 4, D, the number D. The anion is your sulfate. Sulfate, be careful, you have 2 negative. So the acid, because it's a polyatomic ion, so you don't have to worry about the hydro. You change ATE to IC. You call it sulfuric acid. The formula will be H2SO4. The reason you're adding 2 hydrogens because SO4 too negatively charged. The last one, NO2 negative. This anion is called nitrite. You change ITE to, anybody has a question, answer for me? Yes, your ITE to OUS. So you call this acid nitrous acid. Nitrous acid has a formula HNO2. Yes, you are correct. The last topic will be naming binary covalent compounds. We also follow a couple rules. Number one, the binary covalent compounds is typically formed by the combination, chemically combined, of two non-metals. Some of these binary covalent compounds are very commonly used, and they have the travel names, such as your H2O. You don't call it a dihydrogen oxide, but you call it water. H2O is named as water. Number two, for a binary covalent compound, the element with the lower group number in your periodic table is first in the name and in the formula, such as CO2. And the name for this carbon C maintained as carbon, no change. The element is the second and named using the root with a suffix IDE, such as your carbon in the lower group number, oxygen in the higher group number, 14 or 4A, 16 or 6A. So you form, for example, a compound CO2, you call it carbon dioxide. And then this numerical prefix indicated the number of atoms in your compound. This di refers to 2. This number 2, make sure is subscript. That's how you are going to name the binary covalent compounds. Sample problems regarding determining the name and formula of the binary covalent compounds. Totally, we have 3 of them. Number 1, what is the formula for carbon disulfide? What's the name for PCl5? If you given the name and the formula for the compounds, so whose molecule consists of 2 nitrogen, 4 oxygen atoms? Our solution. The first one, carbon. Carbon is C in the group 14 or 4A. Sulfur, sulfide, sulfur is in your group number 6. Therefore, sulfur goes after carbon. Di, meaning you have 2 of them. So therefore, you written down by C1 as 2. So the number 1, you don't have to identify it. C(S2) is the formula for your carbon disulfide. The second one, B, PCl5. P, element P, is called phosphorus. Lots of time I think people call it phosphorus. I have to name it as phosphorus, sorry. Cl is called chloride. You have 5 of this chloride, so this prefix will be penta. The name, the nomenclature of this PCl5 will be phosphorus pentachloride. Phosphorus pentachloride. C, you have 2 nitrogen, 4 oxygen. You have a formula N2O4. This molecule is called dinitrogen tetraoxide. Yes, 2-di, tetra 4. So dinitrogen tetraoxide. I believe at this point we finished our lectures. Thank you so much for listening. So have one more second. I do have a couple examples which are not right, such as SF4. Sorry for that. So you call the monosulfur pentafluoride. We don't do this way. Number 4 is not penta. Dichlorine heptaoxide. Hepta is not 6. So dinitro trichloride, again, we don't name it this way either. So solution for the first one. So SF4, you name it sulfur 4 tetrafluoride. And this dichlorine pentaoxide, di meaning 2, Cl2, hepta meaning 7, Cl2O7. The very last one is a dinitrogen trioxide. So I do have a couple other information, such as how you are going to calculate the molar mass. We are going to study it in your chapter 3 when we study the moles. And then I also have several examples about the molar mass calculation for your tetraphosphorus trisulfide, ammonium nitride. Again, these several examples, we are going to discuss them in the chapter 3 about the stoichiometry, about the molar mass, moles study. And also there are several important information just for you as a heads up, such as the ball and stick model, space filling model, molecular formula, structural formula for different substances. And also I have a couple more slides listed commonly used different monoatomic ions for your future study and related to couple different nomenclatures.